There we go. Okay, so with this one, we have a problem right off the bat. We have two different trig terms. Luckily, this is squared, okay? So we can, these things are very punchy. So we can get rid of the cosine squared x by replacing it with an equivalent expression in terms of sine. How many times have we had to make a substitution like this, right? We don't want cosine squared and sine in the same problem. It's far easier to get rid of the squared term by bringing in a different squared term than it is to get rid of sine x as a single or as a first degree term. So, how many times have we done this substitution? Have we had to eliminate a squared term by substituting something else in its place, right? Now we have everything in terms of sine. And now we have what we would consider a quadratic trigonometric equation. And we don't solve quadratic trigonometric equations, we don't solve quadratic equations by isolating the term. We solve quadratics by setting them equal to 0. Whether they are first degree x quadratics, whether they are trigonometric quadratics, okay? So the first thing we're going to do, I think that makes sense, is to distribute here. So we have 2 minus 2 sine x squared, and then at the same time I'm going to subtract this over to this side, and I'm going to subtract this over to this side, and now that's equal to 0. This is how we solve quadratic equations, by setting them equal to 0. And then factoring, graphing and finding intercepts if you really wanted to. Using the quadratic formula, but the quadratic formula doesn't play well with trigonometric expressions like this. So if I go to clean this up now, you'll see the quirk here. We have negative 2 sine squared x minus sine x, and then I have a 2 minus 1, that's positive 2 equals 0. I'm not a huge fan, I don't know if you are, but I'm not a huge fan of this leading negative coefficient. So how do we do that? You have two choices. You can add all of these to the other side, or multiply everything you see by negative 1 on both sides. So if we multiply everything here by negative 1, now it's positive 2 sine squared x plus sine x minus 1, and that equals 0. So here's our quadratic. Question? So, how do we solve quadratics? Like I said, we can graph it and find x-intercepts. That's an option. Okay. We can factor it, which I think probably makes the most sense. Or we could use a quadratic formula, but not in this case. Okay. So, how does this look like when it's factored? It looks the same as when it's factored with just x's, right? Remember how we talked about how if you had this, and maybe I shouldn't use x, maybe I should use 1. This is when that variable substitution makes sense. How would you factor that, right? We identify what the variable term is, would be sine x, because we have a sine x here, the lowest degree that we can find. And then we express the other one in terms of that. So if sine x is equal to a, this would be a squared. So if you want to work with this, that's fine. But I feel like we have enough experience at this point dealing with the trigonometric term as the variable. So I know I need a leading coefficient for one of these. Whatever the term is that's here, that's what I write in the beginning of each of these binomials. And then I look for two numbers that multiply to be negative 1 and add to be positive 1 when one of them gets multiplied by 2. Whatever number I write here is getting multiplied by 2. So since this is positive, I'm thinking the positive one goes here and the negative one goes there because that product has to be negative 1. Right? That factoring process is the same whether we're looking at x's or sine x's. Right? Then once we have our product set equal to 0, we use our zero product property to solve. We split these up here and here, and we solve. Okay? I don't think we need to go through that entire process again. This is the easy part, right? That's the old stuff. Isolate the trigonometric term, take the arc sine of both sides, dot, dot, dot. Let's save ourselves the time and move on to some other challenges, shall we? I really like this next one, if it's the one I'm thinking of.